So I want to address a point that has been brought up a lot of discussions. I know a lot of people are arguing about this thing, about the coffee and the temperature and that part D, about whether it's increasing or decreasing. And I just want to give you the perspective that is normally taught in calculus and why I'm interpreting it the way, and the way you ought to be thinking about increasing and decreasing in general, regardless of like the vernacular, the language or anything like that. At its core, what you are supposed to have learned, let me pull that up real quick back again. What you are supposed to have learned at its core is that when something is increasing, when some function is increasing, when f prime of x is positive. This is like kind of a core thing in terms of definition. We have to agree that this, not absolute value of it, just that. Something is increasing when its derivative is positive. Now, what most people get confused about is the whole velocity and speed, and like that's such a weird thing. And people tend to think of it as like, well, that means rates are absolute values or anything like that. No. So let's start with a very simple example. Let's say I have a velocity and it's equal to sine of t, and I've graphed it here for illustration. Now, velocity is a rate, right? Specifically, it is the rate of change of the position of the object, right? So it is a rate. This is a rate right here. So, we just give it a different word. We call it velocity. So when is v of t increasing, right? When does this occur from this graph, okay? Now, it occurs from 0 to pi over 2, like this region and in this region right here, this region here, even though it's negative, even though it's going from -1 to 0, we still say that that's increasing. That is an increasing velocity. We include this region right here. We include the region from -pi over 2 to less than t less than. We include that in physics. Some people said, like, that's not how physics works. No. In physics, we would say this is increasing velocity. That is exactly what we would say. We would say the slopes are positive. The velocity is increasing. Now, where people are getting confused about, like, what about speed? But speed is decreasing, right? Speed... And here's where we get with the physical, mathematical, and the physics definition. Speed is the absolute value of the velocity. So in this region here, would we say the speed is increasing? No. But that's because we're plotting something else. We're plotting the absolute value of sine of x. So now I've plotted the speed. Okay, so the blue curve is now the speed. That is the absolute value of sine of t, right, in this case. Now, what do you see about the slopes of the speed? Well, it's decreasing because the slopes are going down. So here, the speed is decreasing. Here, the speed is increasing. Here, the speed is decreasing. Here, the speed is increasing. It has nothing to do with the fact that it's a rate. It has only to do with the fact that the slopes are negative when it is decreasing and the slopes are positive when it is increasing. Velocity, also a rate. It is just a different kind of rate, right? So these are both rates, and they are still increasing when their derivatives are positive. It's just for speed, by virtue of it being an absolute value, when it's heading towards the 0, it is decreasing. Whereas for velocity, it can go up like this, and it can still be considered increasing. Now, you can argue, should things be defined this way? I don't know. Should we say velocity is increasing in here? Right? That's a fair assessment. That's like a fair thing to say. Like, is that a reasonable definition? I don't know. I'm not going to make that decision, but that is how it is defined in physics. That is how it's been defined in calculus. When the derivative is positive, it is increasing. So unfortunately, this problem, so let's revisit the problem again and break it down fundamentally, like what we're talking about. So here's our model. Here is the wording that we're attempting to parse through it. I get there's a lot of opinions, there's a lot of things, but I'm just giving you my perspective on terms of what is the core thing that we learn in physics. In calculus. So this model, we want to determine whether the temperature of the coffee is changing at a decreasing rate or an increasing rate, right? That's the crux of this decreasing rate. So my argument is, if I ask you, is the rate of change of the temperature of coffee increasing or decreasing? Then the answer, I think, ought to be simple. Maybe you guys still disagree. Is we're asking about the rate of change of the temperature in coffee. which is c prime of t. And I'm asking if that's increasing or decreasing. So I'm literally asking you, is c prime of t, the derivative of this, greater than 0 or less than 0? That's fundamentally what it is that I'm asking at that point. Okay? Now, does this wording change that? Is this wording different than this wording? That's kind of what the crux comes down to. Does this have a different meaning than this one? And we can't talk about rates being absolute value because rates are only absolute value in very specific scenarios, like with speed. Like, we don't normally treat rates as absolute value, right? Otherwise, there's a lot of past FRQ answers that are wrong because sometimes we have rates that are clearly negative. You've done related rate problems where the rates are negative. So I don't know. I'm not entirely totally sure like this part here. So the real question is the temperature of the coffee is changing. Okay? It's changing. That's to me that's rate of change. But okay, it's changing at a decreasing rate or an increasing rate. Is that fundamentally different than asking you, is the rate of change decreasing or increasing? I don't know. I think it's harder to defend that means something different, personally. Like, in terms of me breaking down the actual root of the words being said here, is this different than what this is saying? I don't think so. I think it's a lot easier to claim that these two things are equivalent in the English language, but I understand that might not be the case. You might have some interpretation of these words that doesn't mean what I just wrote right here. And so that's really what the question comes down to. I don't have a good answer. But I do want to specify something. I wanted to clear that up, that the reason speed is decreasing, we talk about acceleration and velocity being opposite directions. Okay, this is kind of true. But it's really because it's the absolute value. At its core, it still meets that definition. If the absolute value is... If you graph the absolute value and it's going down, then it's decreasing, right? That's fundamentally what we say. And it doesn't matter that it's a rate or not. It really just has to do with the fact that that's how it's defined. So when it's going down, it's decreasing. When it's going up, it's increasing, right? And so I think there will maybe enough teachers out there who will argue that this does mean something different. So maybe College Board will relent and, everyone will get credit, or it doesn't, they'll accept two different answers. I don't know. They go and they discuss those things and they debate those things. They're above my pay grade. Honestly, I never would have asked a question like this. I don't really neither of these, personally, neither of these statements are very... It's like teaching you to parse language more than like the calculus. If we all understand exactly what's being asked, then I don't think there's a question on the math. It's just a question of like, what does this exactly mean? And can you parse it correctly? And I'm not a huge fan of that because like we don't normally talk about these things. Even if you're an engineer, you're working on something, you're a physicist, you're a scientist, you don't really talk like this necessarily. I mean, there's very rare scenarios where you would. So I ultimately think like this kind of like test of language is not really that important. But anyway, but that's at least my 2 cents on it.